What are lunar distances in early navigation? Imagine trying to find your way across the vast, dark ocean without GPS or modern tools. How did sailors figure out where they were? One clever method involved using the moon as a kind of celestial clock. Lunar distances in early navigation refer to measuring the angle between the moon and another bright object in the sky, like the sun or a star. Navigators used a special instrument called a sextant to do this. The sextant could measure angles very precisely, even on a rocking ship. The reason they used the moon is that it moves quickly across the sky compared to stars. Its position relative to other celestial bodies changes predictably over time. By measuring the angle between the moon and a star or the sun, sailors could figure out what time it was at a known location, usually Greenwich in England. This was important because knowing the exact time at Greenwich allowed them to calculate their longitude, or how far east or west they were. To do this, sailors would compare their measured lunar distance with tables published in a nautical almanac. These tables showed the expected lunar distances at different times. By matching their observed angle with the tables, they could determine the time at Greenwich. Then, by comparing that time with their local time, which they estimated from the sun's position, they could find their longitude. This method became popular in the mid-1700s after the publication of detailed lunar distance tables by the British astronomer Royal Naval Maskelyne. Before that, sailors could only figure out their latitude by measuring the sun's height at noon or by observing stars. But longitude was tricky because it required knowing the exact time difference between the ship's position and a fixed point on land. Lunar distances offered a way to solve this problem without needing expensive and delicate marine chronometers, which were rare and costly until the early 1800s. The process was not simple, though. It involved careful observations, often at night, and complex calculations to correct for atmospheric effects and the ship's motion. Despite these challenges, it was a reliable method for many years. In essence, lunar distances turned the moon into a kind of celestial clock, helping sailors navigate the open sea with more confidence. This innovation marked a major step forward in navigation technology, bridging the gap between basic dead reckoning and the precise timekeeping that modern navigation relies on today.